harmony between an advanced motorized society and the environment, and harmony with people. As we strive to realize an ecologically friendly motorized society, we at the Japan Automobile Research Institute are committed to carrying out advanced research with the aim of helping to create a new motorized society and a friendlier global environment. Two of the biggest problems currently facing the world are energy conservation and global warming. As we look to solve these and other environmental and energy problems, our hopes rest with hybrid and electric vehicles, fuel cell vehicles, biofuels, and intelligent transport systems, or ITS. At JARI, we're conducting research into these clean next-generation vehicles, new energy sources, and intelligent transport systems as we seek to create a motorized society that is friendly to the environment. We're also conducting research into applying energy conservation principles to traffic flow using ITS. In particular, we're pushing ahead with technological development in the areas of automated driving and platooning. Our aim is to realize cooperative driving, in which vehicles communicate with each other and cooperate so that they can move in dense clusters without colliding, like a flock of birds or a school of fish. In addition, we're promoting international cooperative and collaborative activities in an effort to establish a method for assessing the effectiveness of CO2 reduction through ITS. In the field of fuel cell vehicle research, our focus is on assisting the spread of fuel cell vehicles by standardizing methods for testing the durability of fuel cell materials and proposing quality standards for hydrogen fuels. In particular, we test the safety of hydrogen fuel tanks on fuel cell vehicles at one of the most advanced large-scale safety assessment facilities in the world. These evaluations involve fire testing in conditions designed to mimic those of an auto accident. As we at JARI seek to combine high fuel efficiency and ultra-low emissions, we're researching and developing advanced diesel engines and biomass-fueled diesel engines. We're also carrying out combustion observations and simulations as part of our research into a new diesel combustion process based on JARI's own combustion concept. Our facilities are equipped with a variety of different chassis dynamometers to enable us to assess the performance, fuel consumption, and exhaust gases of these clean next-generation vehicles and other vehicles. We carry out comprehensive environmental assessments by measuring the amount of noise each vehicle makes and by analyzing each vehicle's exhaust, its diffusion into the atmosphere, and its impact on our health. To help us conduct these exhaust gas analyses, we have developed advanced analytical methods that enable us to detect ultrafine particles and matter that can be harmful, even in minute quantities. We're developing simulations to predict the extent of the diffusion of exhaust gases in the atmosphere and its effect upon the atmospheric environment under a range of different conditions. As well, in order to study the effect of exhaust gases on humans, we perform exposure simulations on laboratory animals. In recent years, we have also been involved in using advanced molecular biological techniques such as DNA microarray analysis to shed light on the mechanism of health damage. One of the most important goals of JARI and of society at large is zero traffic accidents and zero casualties from accidents. JARI has spent years investigating techniques for reducing or preventing accidents and the damage they cause. In connection with active safety, we're conducting research into driver's aids and other accident prevention technologies, as well as the mechanisms and conditions that trigger traffic accidents. We use the simulated test field on actual city streets to recreate accident scenes and assess various driver assistance systems. At the same time, with the help of an omnidirectional view driving simulator with a 360-degree spherical screen, we analyze the causes of traffic accidents, whether they relate to people, vehicles, or roads, and carry out other research aimed at preventing accidents. We are also concentrating our efforts on research and development of decentralized vehicle probing systems, in which vehicles are employed as sensors that detect dangerous situations and congestion points. The system then shares this information with other vehicles so that these locations can be avoided, thereby contributing to smoother traffic flow. In the area of harm reduction, our work includes using driver recorders to gauge and analyze the circumstances surrounding road accidents, developing human simulation models to recreate the mechanisms behind human injuries during traffic accidents, and researching, developing, and assessing human dummies that can be used to accurately recreate passenger injuries. With regard to human simulation models, we have worked closely with specialists in various medical fields and with overseas research institutes to create a model that faithfully recreates the human body structure, which has subsequently been used to good effect. Furthermore, using one of the world's most advanced collision test facilities, we conduct a wide range of tests for crash safety, including front, side, and rear impact collision tests using actual vehicles, child seat tests using a range of collision test equipment, and pedestrian protection tests. At the same time, we continually strive to develop new testing methods. The various data gathered as a result of these efforts is presented at international conferences and the like as part of our ongoing contribution to the realization of a safe, motorized society. In order to acquire data on the dynamic performance of automobiles, we conduct actual driving tests that cover steering and controllability performance at high speeds, acceleration performance, and so on. JARI has an international class oval proving ground with a lap distance of 5,500 meters available and many test tracks suitable for a wide range of tests. At JARI, we carry out traffic accident investigation training courses aimed at improving the skills of police traffic accident scene investigators, and JICA training courses aimed at educating automotive engineers in various countries around the world. In the interests of contributing to the wider world, we also hold roundtable discussions to facilitate the sharing of information with countries in Asia and to promote energy conservation and air pollution reduction in large cities throughout the region. We actively organize various forums, seminars, and other activities to promote and encourage the use of next-generation vehicles. We also provide a range of information and engage in other activities designed to support and promote the automotive and other industries. We also manage and operate the Japanese Automotive Network Exchange, or JNX, a common network for B2B e-commerce in the automobile industry. In addition, we operate the Japan Automobile Research Institute registration body, which offers ISO certification in relation to environment and quality management systems. Looking toward the year 2020, JARI is committed to responding appropriately to the needs of society and disseminating appropriately up-to-date information. We continue to take on all manner of challenges consistent with our vision of an organization that tackles advanced research and contributes to a global motorized society.